If gravity disappeared for just 1 second, your phone, your chair, even you would shoot into space at over 1,000 kilometers per hour. Your house would rise like a balloon, oceans would drift off, and Earth itself would start breaking apart, all because of one missing force. Scary? Well, that's gravity, the invisible glue that holds everything together. Let's decode what's really keeping us grounded. We all know gravity is the force that keeps our feet on the ground, but that's only a small part of the story. Gravity isn't just an earth thing. It's a universal attraction between two objects that have mass. From the tiniest dust particle to the largest galaxy, everything pulls on everything else. You are pulling on the earth right now and the earth's pulling back on you. The only reason you don't see it is because earth is way heavier. Let's make it simple. The force of gravity depends on two things: how massive the objects are and how far apart they are. Mathematically, it's written as F is equal to capital G into m1 into m2 upon r square. Don't worry about the symbols. Here's what they mean. F is the gravitational force. m1 and m2 are the masses of two objects. R is the distance between their centers, and capital G is the universal gravitational constant, the magic number that ties the entire universe together. This law explains why the moon keeps orbiting Earth without flying off, why planets revolve around the sun, and why everything falls towards something else. No matter where you are in the universe, this law works the same way every single time. Now here's something fascinating. That capital G in the equation is very small. Its value is 6.674 into 10 to the power minus 11 Newton meter square per kg square. Tiny but absolutely crucial. If G were even slightly larger, planets would collapse into each other. If it were smaller, galaxies wouldn't have formed at all. It's this perfect balance that allows the universe to exist the way it does. A small number, but the entire cosmos depends on it. Acceleration due to gravity, or G. Its value is about 9.8 meter per second square, which means every second an object falls, its speed increases by 9.8 meters per second. That's why when you drop a ball and a hammer together, ignoring air resistance, they hit the ground at the same time. It doesn't matter how heavy they are, because gravity pulls on everything equally. Now this small g isn't exactly the same everywhere. It's slightly less at the equator and a bit stronger at the poles, because the earth isn't a perfect sphere. It also decreases if you go higher up, like in airplanes or mountains. That's why astronauts in orbit feel weightlessness. On the moon, it's only 1/6 of Earth's gravity, so if you weigh 60 kg here, you would weigh just 10 kg there. On Mars, it's around 1/3, and on Jupiter, more than 2.5 times stronger than Earth. That's why launching rockets from Earth takes so much power. We are fighting a very strong gravitational pull, and near a black hole, gravity becomes so extreme that even light can't escape. Imagine space-time stretched like a fabric. A black hole is steered in this space-time fabric so deep that nothing comes back out. Gravity isn't just some cosmic force, it affects your everyday life more than you think. It keeps the atmosphere wrapped around our planet. It causes the tides by pulling ocean towards the moon. It keeps satellites orbiting perfectly, allowing you to use GPS and watch TV. Your muscles, bones, and blood circulation evolved because of gravity. Take that away and you would start losing bone mass and strength, just like astronauts in space. For centuries, we thought gravity was simply a pulling force until Einstein changed everything. He said gravity isn't a force at all. Instead, it's the way space and time curve around massive objects. Where a simpler way to imagine this is to imagine placing a bowling ball or a heavy metal ball on a trampoline. It bends the fabric, and if you place smaller balls around it, it will roll towards it. That's not exactly how space-time curvature bends, but that's a more simpler way to understand it. And that's how Earth curves space-time, and the moon follows that curve. We are not being pulled down. We are just following the natural path in curved space-time. Mind-bending, right? We will cover this in upcoming videos. So next time you drop something or feel your weight, remember, it's not just Earth pulling you, it's the same invisible force that holds the moon, the planets, and the entire galaxies in place. But here's a question to leave you thinking. What if gravity isn't constant everywhere in the universe? Could there be regions where it's stronger or completely gone? We will explore that in the next video. Hit subscribe so you don't float away before then. Thanks for watching.